Login accepted.
All right, it seems we're live. Hello, everyone. How was the night? Was it short? Was it long? I think it was pretty short since there's no response. Right, okay. Oh, yeah. I hope you enjoyed the 2 days that are already behind us and that you're going to enjoy the last day of Devoxx Poland. So today, to start with something a bit different, it's not going to be strictly about Java, despite the Java is in the title of today's presentation this morning. It's Go Java Developer, all right? So briefly about me, my name is Piotr Przybył. This is like where you can find me in the social media. I work as a software gardener and software engineer at a company called Atomic Jar. So we're doing test containers and beyond, and sometimes I also work as a trainer, and sometimes I post some stuff on softwaregarden.dev, my personal webpage. Yeah, so for the years, Java used to be the thing I used to, or like the ecosystem, the tool, whatever we call it, I used to be busy with to basically bring some bread and put it on the table, right? So even when I went on holiday, Java was still somewhere around, like just, take a look and it's there. So the question is, who are you? Java developers, please raise your hand. Okay, is there a non-Java developer? Oh, I see a few. May you guys shout out what you're doing then? I'm just curious. Kotlin? Okay, but it's like, okay, some say better Java, some say it's not. All right, so it's Kotlin, okay? All right, so also, before we start, a little warning, safe harbor statement, caveat auditoris, everyone can make a mistake, right? Don't trust ultimately talking heads, verify on your own, and so on and so on, right? Erae humanum est. So this talk, in case you came here because you have this fancy new assignment at your company, and it's about to be in Golang, and you want to learn Go in just 1 hour, this is not a crash course of Go, right? This is not this bootcampish style, or whatever you call it. This is a talk about what a Java developer found intriguing in Go, found annoying in Go, can share with you, and what I think now, but my thoughts, since I'm not a cow, might change in the future, of course. And yeah, I can actually make mistakes in Go, like in pretty other language as well. Okay, like a little explanation, okay? I think I owe you a little explanation. I'm not quite a Java developer. Like during the years, it was like my story started with object-oriented programming, non-object-oriented programming in C++, so like things like structs and whatnot. Then I earned for a living also doing some PHP 3, right when the tuition wasn't enough. I enjoyed writing pure C on System 5. I did some stuff with Scala, and it's still running in production, so it wasn't that bad, I guess. And I even did some JavaScript, Python, some C#, OCaml, and basically you name it. So it's not that I've been doing only Java for, I don't know, so-called career, right? So the story of my life recently, I'm sorry because this talk is like very subjective, I would say. So it's about like my experiences and my recent life. So it's just I got this new fantastic job at Atomic Jar, and I discovered, oh my gosh, they're using Go as well, right? So it's not, apparently it's not only a Java shop, but it looks like C-ish. So I mean, you see ifs, you see fors, right? You see interface. So how hard can it be? It can't be that hard, right? Well, apparently, sometimes it can. Just because it looks so similar, you just start thinking it's like, I don't know, something quite similar to C or Java. But in very aspects, I would say, or at least in quite a few aspects, Golang is different than Java. So things which are shared between Go and Java, at least the way I see it, is that they work, right? They both do a fantastic job when you have to deliver something to production quickly, and it has to be like reliable and working and so on. They both have C-based keywords. They support static typing, or support, I mean, they are about static typing, right? They both have type inference. They are compiled languages, meaning there is a compiler, and if your source code doesn't compile, it basically won't produce the artifact that can be used later. They both have garbage collectors. They provide you memory safety unless you do some really crazy stuff, right? So creating memory leak is always possible. They both have interfaces, and they pass by value, right? Things in Go that I find totally different than they are in Java is that there's no VM, there's no virtual machine. When you wrote a program in Go, and it's running, and there's no virtual machine, apparently. There are structs, there are no objects, therefore Golang is not object-oriented. There is no inheritance, therefore. Dependencies management works totally different. So, I mean, surprise, surprise, they have no Maven or they have no Gradle, right? They have like different files with different style and slightly different philosophy. There are pointers in Go, but that shouldn't scare you off, really. They have different model for concurrency, at least as it is today, right? And there are no exceptions in Go. Interfaces exist, and you will see this interface keyword in Go, but interfaces in Golang work different way than they do in Java, right? I mean, how they are implemented and so on. Because apparently, I mean, they are about the same, like providing an interface, and you implement an interface, or better said, interface is implemented, right? So in this aspect, they are similar, but how they do this is different. And there's also a different way of doing generics, and generics is a pretty relatively new thing to Golang. It appeared in production or in GA version just a few months ago, I don't know, like 2 months or something. So they are still like pretty new thing, not that popular, and are subject to change, right? So that's why today I'm not going to talk about generics. Yeah. So this talk is going to be divided into series of pro tips, right? So like a little pro tip for you, like a takeaway, so you can start thinking in a bit different way when you have to do something with Golang or read Golang code or understand it. But maybe before we go to the pro tips, like quite important thing when it comes to Go is this, or what's also the purpose of this talk, right? So there are idioms, right? It might not be the very fortunate example, but to give you like the understanding, what I mean, even if it's a bit harsh, is like this. In Polish, right, in the mother tongue of majority of us, when somebody passes out, right, to the better words or whatnot, we can say that they kicked the calendar, right? In English, you kick the bucket. So you kick a different thing, but it actually means the same, right? So by saying something differently, slightly differently, you achieve the same, or you pass the same message, the same meaning, right? Or it can be the opposite. Yeah, using the same idiom in two languages, you can get a different meaning. So here it is an example for you. And who can tell me, just by looking at this code, right? See, we are just going to print something, welcome to Go, and then we are going to print this stuff. So what this program is going to print, like what date is going to be printed? I can hardly hear you, so you can shout out.
Like the current date in this format?
Yes, who said that? Okay, cool. I have something for you. I don't know if I can throw it, but maybe you can collect it later, okay? That's waiting for you here, all right? Yeah, exactly. And as you can see, there is no like HH, there is no like M, and you don't have to like think if the uppercase M is for months or for minutes, or how does it work. There is like a special selected date, and you just format the date you want to be used for formatting the time, right? When you print it, or timestamps. So this is like something different than the other C-based languages, right? Like Java, PHP, and you name it. So see, this is like a different way of achieving the same, or like passing the same message, or achieving the same goal. So this is what I mean when that you have to learn a set of idioms, like new idioms, when it comes to learning Go. So yeah, pro tip, the very first pro tip, right? When searching for stuff because you're learning Go or you'd like to achieve something in Go, maybe instead of searching for Go, just search for Golang. I mean, it's pretty intriguing how the company that started, or was about, or we associated in our brains basically with their search engine, how they created a language called just Go, right? So in many forums, in Stack Overflow or like in many other places, it's basically referred as a Golang, right? So if you try how to do something in Go, and it doesn't just give you any meaningful results, maybe you'd like to try how to do something or how to do that thing in Golang. And I think chances are that you'll get something more meaningful or more useful. Another pro tip for you. By the way, if you have any questions, just raise your hand, wave it, or get my attention, hopefully without throwing hard stuff. It's a general learning principle, but I can't stop saying this enough. If you just want to learn something about Go, it would be better if you just forgot you were a Java or Kotlin developer, right? Let's start with this principle that there are variables, there's memory, there are some conditionals, right, like ifs, there's maybe some concept of looping, there are some functions, and like that, calls on the stack and whatnot, and that's pretty much it, right? Forget about everything else. That would be easier. Right? Don't try to write Java using Go's syntax. That might not work, basically. Yeah, before learning Go and before learning anything else, be eager, and be open-minded. Another pro tip is that if you'd like to check something, how it works in Go, you don't necessarily have to install Go on your machine. There's a thing called Go Playground. I would say it's pretty sophisticated stuff, right? It's just it. See, you go to go.dev, and then you can type your program in Golang, and maybe we could copy the one that we had here, since I didn't run it. And another question: what time will be printed when I do that in Go in this Go playground? Sorry? Oh, we've lost visuals. How? Oh, it seems that the cable is something. Okay, thanks for the heads up. Okay, so again, the question is, what time will be printed here?
Current time on the server side?
No. No, it doesn't depend. It doesn't depend. Sorry, Mr. Consultant, it doesn't depend this time. No. Let's just run it, okay? See, this is the very purpose of Go Playground, that you can play with stuff, right? But it has a few caveats, and you have to be aware of this. The time it's going to be used here, command work. Do I have connectivity? I should have. Why is it? Yeah. So it's this time. And when I run it again, it's going to be the same time again, or not? Yeah, the time passes since, right. So it's like waiting for remote server. No, it's the same time, as you can see. The thing is, it's like a sandbox, and it always starts from the scratch, right? You don't get access to like files or something, and it just always starts in the very same time or time point from the past, right? So you have to be aware of this when you play with the Go Playground. But pretty much everything else, it's working. Very nice thing that you can see when we misformat this stuff. I can click format, and we'll get formatted again, and I can even click share, and then I can share with my friends, or Stack Overflow, why this code isn't working, or stuff like this. Very useful when it comes to sharing or asking for assistance or stuff like this, right? Go Playground. I really encourage you to use it should you be learning Golang. I hope so. Okay, so the next pro tip is that there's a thing called native executable, right, in Go. Still have visuals, okay. So after compilation, there's a single artifact, right? On Windows, that would be this .exe file. And this is it. That's just the whole thing, right? You don't have the concept of, I don't know, like jar files or other dependencies. I mean, if you rely on a stuff that's needed by an operating system or a library you're using, right, or the code you wrote, that depends on something that is existing, for example, in .so files, right? Of course, this library has to be installed, has to be present in the operating system, right? But like if you do like regular stuff, let's say, I don't know, this famous how to implement some kind of sorting or whatnot, it's not going to depend on anything else. You just ship a single executable, and that's the thing that's going to run basically, or to be used for running. And some say this is like similar to Growl, right? Because you can get like this native executable, and it just runs without external dependencies. Another pro tip for you is that type inference is very common in Go. And if I were to say, I would say it's even more popular than in Java, like in my opinion, but it might be biased, right? And it kind of like resembles what we have with var since Java 10. And what I mean by this is how it actually works in Go. So this is a very legit and proper way of creating or declaring a variable, right? So we say that this is going to be a variable, this is going to be its name, rn1 in this case, it's going to be of type integer, right? The thing is, we don't see it that often in Golang. I mean, it's still legal and correct, but it's like not popular. This is way more popular. So you just say that this is a variable and is rn2, that's the name, and the type is inferred like pretty much in Java, like from what's initialized locally here, right? And I would say most of the time you would see something like this, and this is not that it's Pascal, right? It just means basically something like this. Only we even like abbreviate we make this whole declaration shorter by not using var. So hopefully that should work. Let's see if it works. Come on, demo goats. Apparently it does, right? So yeah, we got a random number 3 times, right? I mean random up to 20. And as you can see, all 3 are equivalent. It's just this is like I would say the most common way. So this means type inference basically. And as you can see, we don't even need var like we need in Java to have that. So yeah, it's quite common. Another pro tip is that functions in Go can return multiple values. Right? Be no surprise by that. And what's important that all these values have to be consumed or verbosely ignored, right? So it's because one of the things that are like, I mean, I don't know if it's like official statement of the creators of Golang, but the way I see it is that it's an attempt to make a language that's like very nice for the machines because it's like relatively easy to compile. You know, it's fast, like lower levelish. Some would say something like this, right? So it's like machine friendly, basically, but it's also and it's human friendly. Like so, it's to reduce the number of common mistakes. So you, for example, forget to you wanted to use something, but you've just forgotten to use something, right? From the core. So it's like to make things explicit and required by the compiler and whatnot. So this is what such a, manifestation of such an approach, I think. And how does it work? It works like this. You see, we have a function. This is how we declare a function in Golang, and it's going to the name is full name, and it's going to return 2 things: string and string, right? And we just return John Doe, and when we call the function, we have to assign it to, all the values returned have to be assigned, unless I'm happy to ignore, let's say, the last name, then I go with an underscore, and of course I don't have anything here, and then when I rerun it, it's just welcoming John, right? But this is how you do it, and how you have to do it. You can't just go something like this. It won't work. It won't even compile, right? So it's like, you have to decide what you're going to do with stuff that's given to you back from a function. And some say it kind of like resembles what we have in Waiver on, with all these tuples, or like in record in Java. recently, or not that recently. Another pro tip, Go is very idiomatic, as I told you. So there's stuff like OK idiom, done idiom. Like in Java, we have, for example, this try with resources idiom. Right? Try to explain to programmers from, like, let's say, quite remote languages that there is a thing that you don't close file manually, or I don't know, some kind of like file reader or writer, whatever they might call it, or stream. It's just you use that file name somewhere in this try clause, and then when you leave the scope, it's automatically closed and released, right? And this is like the way we should think about it, I guess. So for you, I have here the idioms. So we're going to see now this OK idiom, right? So we have a function that's taking like a UID, and of course it's like a dummy demo function just to like show you how it works. So again, we're going to return string and boolean, right? And the last thing by the convention in such case is this, like, is used in this OK idiom. So if it's true, it means we have returned an actual value. So it basically means that whatever we return here in, like, before this bool actually makes sense. It's OK, right? And if we return false here, it means that it's not OK. It basically means nothing. It's rubbish. Just feel free to ignore it, right? And this is how we see that in action. So if the thing is OK, right, then we can safely consume first name and last name. I mean, the other values returned by this function. And if it's not OK, we just, let's say, for example, the user is unknown, or something bad happened, you know, stuff like this. Let's see how it works. OK, so please welcome John Doe. And John Doe again, not that very random. OK, and now we can see user 0 unknown, right? Because it was apparently false, because it's not OK, there's no such user, right? So this is like the concept, like we don't return like nulls or optionals, empty optionals, or something like this. You rather use this OK idiom. Another pro tip, and that's harsh for many people, there are no exceptions in Go. And errors are returned as the last value if there is an error, if there's something wrong, right? And it's in the opposite fashion than either left and right, because in using either, when something's right, it's on the right, and you have the error on the left side, right? Because it's not right. In Go, it's opposite, pretty much like in the Go, OK idiom. Righty. So errors work like this, and it's quite, like, see, the code is quite similar, I would say. It's just now instead of Boolean, because let's say having just the knowledge, if it was OK or if it wasn't OK, is not enough. Let's say we need to have a reason, right? Like what went wrong. Therefore, instead of just having a Boolean, we decide to return an error. And the error, just by the convention or by the idiom, is the last value returned of these multiple values. So as you can see, if the UID in this very particular foolish demo case, if it's 0, we just say it's incorrect, right? Incorrect UID. And then if it's basically anything else than 0, 1, or 2, we just return no such user, right? And then again, if there is no error, if the error is, as we say in Go, if the error is nil, then it means that these values are perfectly fine, they are OK, and they can be used, consumed, and they have some sense, like they have some meaning. And if the error exists, then anything returned here, like apart from the error, is just rubbish. Don't care about that. OK, so let's try to run this stuff. OK, so now it's Susan Doe, and see. Yeah, so we got into this branch, like incorrect UID, and maybe I should go for like 10. And John Doe again, 0. See, user 4, unknown, no such user, right? So it's just more than this simple OK, not OK. All right, another pro tip is there are no objects, and therefore there is no inheritance in Go, as we know it in Java or in Kotlin, right? And there is even no implements in Go. But you can implement an interface in an implicit way. And this, sorry, yeah, this is how it's working. Okay. Let's say that the like generic error, basically the message is not enough for you, and you need to pass something else, right? You need to return something else. And so let's create this structure. See, we declare a new type, incorrect UID, and it's going to be a structure, and it has just one field, this integer, right? And we create a function, and this is looks a bit funny, right? Because it's a function of name error. It doesn't take any arguments. It returns string, but you know, the thing here, it means that it's a function that can be called on this structure, therefore we call it a method. So basically this is how you declare or how you write a method in Golang, and it's a method that you can call on this structure, basically. So again, we have this function full name, and it returns error, and here we just return incorrect UID, right? Because this is what we decided to do. And when we run this code, yeah, it seems to be working, right? So it's okay, it compiles, it works. And as you've seen just a second ago, but maybe we'll get that again, yeah, it shows this incorrect UID 0. And as you can see, it comes from here, incorrect, incorrect UID. No, because we print it from here. Okay, yeah. So we don't print the error. It's just it should be the generic error that then will be printed. Anyway, it works now, and let me just say that we don't have this, or maybe even not that much. Let's rename this as error MSG, error message. Okay, and suddenly it doesn't compile. So it seems that we broke the code, and how is that so? Say cannot use incorrect UID as type error in return, and incorrect UID does not implement error. So it happens at the compile time. It's not runtime, but it kind of like resembles this, you know, duck typing. So for our incorrect UID structure to be treated as an error, it means that it has to have the methods which are declared in the error interface. And this is it. The error interface just requires that you have one method called error and that it returns string. Any structure that has a method with such a signature named error, taking nothing and returning string, can be used as an error in Golang because it's now implementing this interface. And this is exactly the case of our incorrect UID structure, right? So there is no implements here or no extents here yet currently, just because of the presence of this method. This stuff is implementing error interface. Another pro tip: if you need to inherit something via composition, is it doable? Apparently in Go it is. So again, there is no OOP, no inheritance, but kind of like something that can be used in this fashion, or some call it inheritance by composition. Okay, so this might not be the very best example in terms of animals, but it's like, okay, let's just do that. Okay, so there's a swimmer, and the swimmer can swim in a certain style. Okay, and there's a method. So when we tell the swimmer to swim, it just says that it's swimming in this given style. And similar for runner. Okay, the runner can run in a style, and when we tell a runner to run, it just runs. Okay, and then let's say we have a hippo, and a hippo kind of like contains swimmer and runner. Basically, as you can see, it's like just like we had in the previous example, we had this UID inside the structure. Now we have this swimmer and runner inside our hippo, because hippos can apparently swim and run, or at least like move on the land, let's say. And here is how I'm creating the hippo, right? So it's a hippo consists of a swimmer with a slow style and runner of fast style. Whether that's true or not is not that relevant. And this is pretty obvious. Since this thing is inside, okay, you can go and on Hippo, you can go get the swimmer from the inside and make it swim, or make the runner take the runner from the inside and make it run. Okay, this is like obvious for Java developers. But what you can also do is this. Because Hippo contains swimmer and runner without giving it like any alias names, like S or H, right? I mean, this of course breaks this thing, because here we'd have to go for S and R. Sorry, should be R, yeah, right? Then, I mean, this is how it's supposed to work. But if you add an alias, you lose this inheritance via composition. That's why it might be wise sometimes, or needed, to just not give these internals any like variable name or field name, whatever we call it. Right? It should be like field name or an alias or whatever, because then it makes this thing work as well. It means that on the Hippo you have the swim method and run method. Let's try to run it. Yeah. So as you can see, if this is your goal, right, then you have to inherit via composition like this way, basically, or this way, yeah, and this is how we construct the Hippo. Not that obvious for Java devs or like OOP developers, but apparently, as you can see, composition can do very nice stuff, and you don't necessarily need to have inheritance. Another pro tip: methods and functions can't be overloaded. And this is again to make things obvious for like users of the language and also for the computer, right? So if I have a method called do on my something, right, I can't have another method named do taking a different list of parameters. I mean, this is perfectly legit, or would be perfectly legit, like in Java, right, in C# and other languages like this. But apparently in Go, there is no method overloading. If you have used the name, right, for a method, and it doesn't matter like what's the list of the parameters, it can't be reused. It's just to make things very, very obvious and less error-prone. So yeah, don't be surprised that you can't use or reuse the same function name or method name, for that matter. Another pro tip: access modifiers. How many access modifiers are there in Go? Does anybody know? 0, exactly. Who said 0 first? Okay. You'll have to go downstairs if you want to get these, okay? I'm not able to throw them that far away, sorry. Exactly, there are 0 access modifiers. There are no access modifiers in Golang, right? But can we block access to certain stuff in Go? Yeah, we can. And we do it this way. We have these utils, okay, maybe not the best package name in general, regardless of the language. Here, just for demo purposes, it works. So this stuff is accessible from other packages, and this stuff isn't accessible from other packages, right? Here inside, I can access everything, right? As you can see, the code compiles. I can go for accessible and inaccessible variable. And here, when I try to access it, I can only get the accessible, and I can't get the inaccessible. And you may ask yourself, is really Go's compiler that smart that he can understand English, like with various synonyms or whatnot? I'm afraid it's not the case. It's just about being uppercase or lowercase. And that's pretty much it. This is what dictates the access rules. So whatever is or starts like a function, right, or method, or a variable name, if it starts with a lowercase letter, it's visible in this package only. And if you want to if you want it to make it accessible outside, you have to start with an uppercase, like, I don't know, shout it out or something like this, right? So that's why this thing is inaccessible. Beside that, the example should work. See, this is accessible, this is not accessible. We printed this accessible here, and this say hi comes, and you see it's like util say hi, right? Comes from this thing. So apparently things can be, let's say, public and private, and there's nothing in between. Since there's no inheritance, there's no need for like protect it, right? Yeah. Pro tip number 12, arrays in Go aren't like they are in Java, basically. So arrays are values. And some say in a way it resembles what we're going to achieve thanks to Valhalla in Java. So how does it work? We have this function, and this function is named print A3. It's like a hint, right? And because it's going to print an array of 3 elements. And these aren't just any elements, but we're going to print an array consisting of 3 strings, right? So this is this function, and inside we're going to print in a pretty naive way the first, the second, and the third one, right? Let's see if this example works. It should. Okay. So now, as you can see, I'm declaring this array of 3 elements, okay, and I'm printing it. And this is another way of declaring an array. If I don't know how many elements I'm going to have, when I declare this array, I can just go for a dot, 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 right? And again, I can print this array, right? And then I can create an alias for this, or another variable, being at this time exactly A3. And then, as the first element of this A3 bits, I can assign DD, right? And then when I print both of them, as you can see, it was only replaced in this second, or this alias, right? And not in the first one, because it's a value, it got copied, right? So I'm just replacing, a cell or like, let's say, a value at a given index only in the second value, not in the first value, right? So this is like different from Java, and I can't do such thing. I can't reassign or set something else to this A3 because A3 already has a type, and this type is array of 3 elements, not just array of strings. It has to be an array of 3 strings, right? So the number also is significant, right? It's important. And I can declare a new variable like this, and when I try to consume it in this function, it doesn't work as well because this function expects that there will be the argument will be an array of 3 strings, not an array of 4 strings. So as you can see, the size of the array is also part of the type, right, of the array. And you may ask yourself, why is that so important, right? Why couldn't they just do it like everybody else? One of the reasons is efficiency, right? Being machine friendly. Again, think about it this way. If you have like a regular array, okay, and it can have like a different size, where do you allocate it? In memory. It has to go to heap, right? Because you don't know how big it's going to be. But if you have an array which is acting as a value, then like pretty much every other, let's say, primitive value, you can put it on stack, right? And the stack has a very nice property that when you finish the call, you just unwind the stack. And when you make a call, you just add something on top of stack, meaning you don't need to worry about garbage collection, right? Because it just goes up and down with the calls of functions or methods. Right? So this is, like, as you can see, a manifestation why it can be nice also for the machines, right? Not just for human beings. However, you may ask yourself, so how do I create these types when I can keep a different, differently sized stuff in Golang? It's still possible. Then we use thing called slice. Okay, we use slices. As you can see, now I don't have the size declared. Means it's not an array, it's a slice. Don't be confused by the two, right? No size, it means it's not an array, it's a slice. And you want to Google for slice, how to do something with a slice. And this is, again, like an idiom, how to iterate or print something from a slice, like the contents of the slice, all right? And I'm declaring a slice of 3 elements, and I'm printing the slice. All right, so it's ABC. Then I'm declaring or assigning a new slice to this earth variable. So it's def, as expected, I guess. And then how will the replacing work? So again, I'm creating an alias, right? And then I'm assigning DD to the first element. And as you can see, now it got replaced. So it's important whether you're using slice or an array, right? Because when I print both, both get stuff replaced here. But now I can also append stuff, right, to this slice. So when I append element G to this SB, I expect, of course, DD, E, F, uppercase G. That's obvious. But how the replacing will work again then, if I try to like get stuff back to the initial point, right? And instead of doing this, I want to assign the lowercase d here. Then I will only replace it in the second one, not in the first one. And how, I mean, what the, how come so, basically? And so the thing is, you need to know how slices are implemented. It's basically a structure that has a pointer internally to an array, and it works in a similar way, like it resembles array list. So it it adds elements or appends elements as long as the array is there. But once it reaches its limit, right, and we didn't make this slice bigger than the initial 3 elements, it means when it gets bigger, then internally, inside this slice, we have to allocate a bigger array, right? And the bigger array is pointed to using a pointer. And because the stuff got copied, right, it doesn't share the same pointer. We have 2 pointers, both, one's from these S and one's from these SBs, pointing to initially the same array. But once the appending happened in SBs, it meant we had to create a new array, and the pointer from SBs got, started pointing the second array. That's why it's a bit tricky once you start appending stuff and like share the reference to the same thing, to the same slice from many places. Please be aware Please be aware of this. Okay, to save you some headaches. Another pro tip. Slices are wrappers around pointers and arrays, and size independent, append friendly, and only append without understanding pointers will get you into the trouble. So this is what I have shown you, I guess. Yes. Another pro tip: use Go FMT, and this is what I freaking love about Go. Okay, when we have indentation, shall we use tabs? Shall we use spaces? Okay, how many spaces? 2? 4? 3.5? Exactly. There are no such problems in Go. I'll show you just in a second. Let's just go for this code, okay? Let's say I will add some spaces here. I will make some indentation using tabs here and some spaces here. And now I should be able to even see the IntelliJ did that for me. But in the terminal, I could also go for like Go FMT. Is that the syntax? Yeah. 1, 2, 3. Et voila. It goes to the same formatting, right? So it's not like in Python that when you make a mistake with this, indentation, your code suddenly works in a different way, right? In a Go, they not only defined like the language rules or what happens and whatnot, they also defined how it should be formatted. And I love it because it means that we developers can stop arguing about 2, 4, or 3.5 spaces. We can just focus on being productive, basically. And I really encourage you to do the same stuff in Java using, like, for example, Prettier, right? We just have automated rules for formatting at every commit, and that's it, right? No worries, no headache related to how many spaces or tabs versus spaces or whatever. That's why in Go Playground they have this format button, because the rules are well defined. Pro tip 15. Threads might be too heavy, and sometimes they're not flexible enough, basically, my friends. So we might want to go for something lighter, right? So initially it was processes, right? We thought that it will be enough. We, the IT industry or the computer science folks, we thought that it might be enough just to have processes. We just fork a process, and the process will do something concurrently, right? Or at the same time, basically. But then we discovered that processes are too heavy, so we invented threads, right? And threads were okay. We even used this thread per request, right? Idiom or paradigm or approach for quite a long time. But then we discovered that threads might be too heavy again, right? So like in Java, we are going to have project Loom, which is supposed to be like in preview in Java 19 this September, good stuff. I really recommend it to you to take a look at it. But in Go, we have something else. We have Goroutines. And Goroutines aren't thread. They aren't even lightweight threads. They are articles for you if you're curious why is this the case. Yeah, kind of like Loomish in their nature. So just quick demo for you. Again, this should be working. Demo goats. OK, yeah, it does. It works. Fantastic. How nice. All right. So we have two functions, right? This is an anonymous function. See, it doesn't have a name. Therefore, it's like an anonymous function. And again, we are using, I mean, this is the whole example. OK, this is print string, sorry. So it prints numbers from 0 to 100, right, line after line, and with this S string, whatever that is, right? So in one function, I'm printing hi, and the other function, I'm printing hello. And by adding go here, when I call this function, anonymous or not, then it means I want to start it in a Go routine, basically. So it's going to run concurrently. And as you can see, this is exactly what happens. So we have this hello started, and it started even before we saw any highs, right? And it's hello, 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 hello. Yeah, in this case, it went to the very end. Let's rerun it. This time, it's the opposite. Like the highs got first, right? And let's see yet another time, because sometimes the kind of like, yeah, this is what happened. See, we saw 4 highs or 5 highs, right? We saw 5 highs, and then it started to print hello, because they print to the same, of course, the same terminal, right? But they do stuff concurrently and so on. And this is the like to make sure I don't exit, like in Java, when you have a daemon thread, right? Your process can exit anytime, and only like non-daemon threads are blocking it. So if you want to achieve the same in Golang, then you make sure that you use so-called wait group, right? And you say that you want to wait for 2 in this group, and defer means it's something like finally. What we have in if you have like go, try, catch, and finally in Java, right? So the finally is going to be called as the last thing, no matter what, and this is like what the defer does, right? So when I'm about to finish this function, basically after I'm done printing string, then I want to call done on this wait group, and the other function does exactly the same. Therefore, this WG wait just waits for this wait group to be OK to like proceed, and since there's nothing more to proceed, the whole thing would exit. So as you can see, I can't say threading, but the concurrency is a bit different, yet it might be more efficient, at least compared to threads in other languages, right? So we just use this Go routine, and that's it, right? Just one thing, please use Go, not when you declare, I mean this Go for going for Go routine, not when you declare a function, right? But when you call it. So it should belong to the call side, not to the declaration side. One last pro tip, I guess, is this, that, for example, down calls. If you attended my talk yesterday, we were talking about this in Project Panama in Java, how to make a down call using C-linker and whatnot, right? And in Golang, apparently it might be even simpler, right? Yeah, it resembles Panama. So how does it work in Go if you have stuff in C that you like to call? We have this like artificial or special import C, and as you can see, sorry, no pun intended. As you can see, I have a piece of C here, right? And it's like colored in a special way by IDE because this IDE is pretty smart, right? So it like uses the syntax coloring as if it was a C file, and it's not a C file. It's just a a comment here, right? It's a multi-line comment followed by this import C, and what it does is just it gets thread ID. And also prints this greeting. So what I'm going to do now 100 times, something similar, is just I'm going to get this greeting because I'm going to create C string using this C, right, imported stuff, and then I'm going to call this function greet, right, here. as you can see, 100 times. And this is exactly the same program, only this time I'm also going to print the thread ID. Let's see if it works. Yeah, so as you can see, it works. So I get the highs from thread 354120 this time, and hellos from 354108, right? So in this very case, this Go routine was like running using this thread according to this call in C. So as you can see, calling C is not a big deal in Go. It's a bit more difficult if you have to create these app calls, and it's because, as I told also yesterday, because C doesn't have a garbage collection, doesn't have memory compacting, and because it doesn't have memory compacting, it means that stuff is always in the same place. And in Go, when you make an app call, stuff might change, might get garbage collected, right, and moved through the memory, and therefore there's like a special layer needed to make this stuff operational, basically. So that was it. That was all the pro tips. If you got hungry, if you'd like to learn Go more, because now I hope you're aware of like a slightly different syntax, like existence of new idioms and whatnot that you have to clear your mind. If you got hungry, please, I recommend you reading Learning Go by John Botner, or like a series of very, very nice posts by Dave Chaney, Practical Go. There is Go by Example channel on YouTube. It's not that super new, but it's still very useful, I would say. Sorry, Go by Example is like official tutorials, right, and documents, and Just for Fun is the YouTube series. Takeaways for you, if your friends ask you outside the room what this talk was about, it was about unlearning, learning, testing, and growing your brains, experimenting, having lots of fun, enjoying boring and machine-friendly language. Go is meant to be boring, as you've seen, because there's no method overloading, right? And appreciating both Go and Java, as they are both fantastic languages and do their job, and you just, as a proper software engineer or a software specialist, you can use whatever tool makes you finish your task in the best and most efficient way. And of course, let's appreciate other languages too. I always ask you, not just for my talks, but for everybody's talks, to provide some feedback. So ideally, you can open your Devoxx app and rate our talks there, right, or whatever the conference provides you. In this case, since we see each other, I can accept feedback provided in any way, including paper forms, right? If due to whatever reason you can't open this Devoxx app, or you don't want to open this Devoxx app, or you're watching this presentation a few weeks or maybe even months later on YouTube, please go to this URL and fill the short survey, which is anonymous from my point of view. Okay, a few folks taking pictures. All right. Thank you very much. Go, go, Java developers, at least for fun and sake of experimenting. That was it for today. Thank you very much.